In this video, we're going to look at the instantaneous rate of change and look at how it changes as we look at a graph. So here what I want you to do, this is the graph of y equals x squared. I want you to think about, I've drawn a tangent line here, so the green line is the tangent line. I want you to think a little bit about what's going to happen to this tangent. So the tangent is currently, the x value here is at -4, so that's this value right here. The x value is -4, so that's in here. And just kind of notice what happens to this tangent as we go. And maybe you can make a prediction. What's happening to the instantaneous rate of change of this function as we move from left to right? So for instance, as we move from x equals -4 to x equals -3 to x equals -2 to x equals -1, and so on, x equals 1, 2, 3, 4. So think about that, and then we'll have a look as well by looking at the actual tangent. So here's the tangent at x equals -4. Maybe you could try to describe it. Well, it's a line. Obviously, a tangent is a line, but it has a slope that's negative since it's pointing down and to the right. It looks very steep. Look what happens as we move to x equals -3. So here was -4, here's -3, -4, -3, and here's -2, x equals -2, x equals -1. Now let's jump it over to x equals 1. There's 1. Here's 2, 3, 4. So what do you think is happening here as we move from left to right? Well, when x was equal to -4, you can actually see this -8 on the screen here. This is the slope of the tangent. So it's the slope of that green line. So the slope here was -8. And when we move over, the slope is -6. Then it's -4. And then it's -2. So you can see that the slope is decreasing, and you can see that with the line. The line went from being very steep to not quite as steep. Let's go into the positives now and see what happens. So obviously something happens here, and all of a sudden the line is positive. It's sloping up and to the right. So at x equals 1, the slope is 2. At x equals 2, it's 4. At x equals 3, it's 6. X equals 4 is 8. That's that y equals 2x function that we've talked about before that represents the slope of this tangent. One of the things that, so you should have noticed that the slope starts off negative, it gets smaller and smaller, and then it turns positive. What I want you to think about is what happens right in here between where the slope of the line was negative and where the slope of the line was positive. So take a second to think about that, and then we'll talk about it. So let's have a look here. What happens when x is equal to 0? Well, you can see that when x is equal to 0, that's this point right here along the vertex. And you can see that the tangent is a horizontal line. Well, what is the slope of a horizontal line? Well, the slope of a horizontal line is equal to 0. Now, I want to have a look here. Is this just a fluke? Here we have this function. It has a minimum value, and the slope of the tangent at the minimum value is equal to 0. I'm just going to change our function a little bit. I'm going to make it y equals -x squared, so that we can have a look and see what happens. And as you can see here, the same sort of thing happens. Let's just go through that same process. When x equals -4, the slope of the line is positive and it's steep. -3, it's not as steep. -2, it's not as steep. Not as steep. When we switch over to the positive x values, you can see that the slope of the tangent is becoming steeper. Negative, I should say, and steeper into the negative. So we're getting a larger negative value for the slope. And again, let's have a look at what happens between where the slope was positive and where the slope was negative. So if you look at this, you can see that at x equals 0, the slope of the tangent is equal to 0. The real power in this, and this is really a lot of what calculus is about, but the real power in this is that once we know that the slope at a minimum or a maximum is 0, then we can find a max or a min by finding the function that represents the instantaneous rate of change, setting that equal to 0, and then solving for x, and that will give us the x value where the max or min happens. Now, we've talked about how to find max and min values of parabolas in the past. So for example, if we had a function that looked like, let's try this one. We won't make it too big. Let x plus 1 times x minus 2. We have this parabola, and we've talked about how we can find the vertex. So if we know where the zeros are, if we don't know where the zeros are, we can always find the zeros. Well, we find the zeros, and the vertex has to be halfway in between. So that was one way of finding the max or min. Completing the square was another way. Well, here's this other way that we're going to talk about. We'll talk about it quite a bit in this course because these maximum and minimum values are really important to us. This other way is to find the function that represents the instantaneous rate of change of this graph. And then once we have that, set that instantaneous rate of change function equal to 0. And the reason for that is we want to know, where is the slope equal to 0? Well, the slope is equal to 0. I can't quite get there on my graph because it's not an integer value. But it's equal to 0 somewhere between these two values right here. So somewhere between x equals 0 and x equals 1. And if I had, I don't know if I can change the slider here. Let's just change that. We'll change this to -4, and we'll just change the step value to 0.1 just to get an approximate value here. So again, I'm just going to slide that along, and we can see that the slope is equal to 0 right there. In fact, see, you can see that it's a horizontal line. You can see that our slope is equal to 0. So when x equals 0.5, we have a minimum. So that's how we can use the instantaneous rate of change to help us find max or min values. We'll spend some time looking at an example so you can see the sort of details of the algebra there.